Okay, you guys ready to go? Yes, okay. Please, we have to get through this, okay? Okay, a polynomial function. I know you guys have seen this f of x thing before, okay? All it means is that when you see this part, this f of x, that just means that you're talking about a function. That's why the f is there, okay? It's called function of x. That's all it means. And what we're going to do is we're going to talk about the zeros of a polynomial function. So basically, what number do you have to plug in to get a 0 out of this, okay? So this is what a polynomial function is, and let me explain the zeros. We're going to do an example here. It's going to say this: f of x is equal to, we're going to do x squared plus 11x plus 18. Okay, and we're trying to find the zeros of this. That's the whole goal here, is to find the zeros, and we'll explain what that is. We're going to find the zeros. So, here's what we're going to do. We're going to take a look at this. What is that? What type of polynomial is it? It's a trinomial, exactly. And the leading coefficient is 1, so we're going to do a diamond problem again. No big deal. Okay, so 18 goes on the top, just like you guys told me before. 11 goes on the bottom. Everything's positive. What two numbers can we use here? 7 and 2? No. Let's say 18. What two numbers multiply to 18? 1 and 18, 2 and 9, 3 and 6. Which one do you think it is? 3 and 6. Is 3 plus 6 11? Yeah. 9 and 2. There you go. 2 and 9. So we're going to factor this, right? So f of x is now equal to x plus 2 times nx plus 9. All right, now, the goal again is to still find the zeros. So what we're going to do is we're going to actually set this whole thing and pretend that this is equal to 0 for now. If it was equal to 0, what would I do? I would just use the zero product property. Remember the ZPP? So, x plus 2 would be 0, or x plus 9 would be 0. So what are my two answers here? Negative 2 or negative 9. So, what's the significance of these? Let me show you. If we write down the original problem, f of x is equal to, what was it, x squared plus 11x plus 18. And what two answers did we find? Were zeros. That's exactly right. So these right here, these are what we call the zeros. And the reason they're called zeros is because if we evaluate f of negative 2 into our equation, we're going to get a 0 out of this thing. Okay? So negative 2 squared plus 11 times a negative 2 plus 18. So f of negative 2 is going to be equal to, okay, let's hear, what's 11 times negative 2? Negative 22, right? So this would be negative 22, and then this is a plus 18. And then I still have a negative 2 squared. So f of negative 2 is equal to, how much is negative 22 plus 18? Negative 4, right? So there's going to be a negative 2 quantity squared. And then a minus 4. How much is negative 2 squared? 4. So f of negative 2 is now equal to 4 take away 4. What does that give us? 0. So f of negative 2 is equal to 0. That's what that means. So you got to think of it like this. So negative 2 is a 0 of the function. And negative 9 is also a 0 of the function. If we were to plug in f of negative 9, we would also get a 0 out of this thing. Okay, let's do one more. I realize we're going fast, but it's the same idea over and over again. Let's do this one. Let's do f of x equals x squared plus 5x plus 6. All you got to do if you're solving for the zeros is pretend there's a 0 here and solve it just like you normally would. We have a polynomial function. We know 6 goes there. We know 5 goes there. What are the two numbers on the side? No, not 6 and 1. 2 and 3. Very good. So 0 equals x plus 2 times x plus 3. Use a zero product property. X has to be what two numbers, you guys? -2, or x has to be -3. And those are your zeros of your function. And that's it. So if you evaluate f of -2, you're going to get a 0 out of it. Or if you evaluate f of -3, you would get a 0 out of it. And that's why they're called zeros. Does that make sense? Yep. All right.